Okay, people. So let's define the magnetic field for an infinite sheet, specifically an infinite sheet of current. Let's say this is an infinite sheet of current, current running through this sheet. This is z component, z axis, this is y axis, and this is x axis. Now this current is what? Y ds, which is equivalent to the current element ideal for a line current. This is not current actually, this is actually representation of current element, which is kds, which has an unit of ampere meter, or the unit of current and multiplied by the unit of length, which is kds for this sheet. And now let's say a human, this is an eye of a human, let's say my drawing is bad, I know. A human is watching to all those stuff from z equals to 0 plane or xy plane. Simply we can say someone is watching from this side, that is, he is watching this plane, the whole plane he is watching. So what he will watch? He will watch just a straight line. This straight line is this xy plane. So along this, it is x. He is watching this. This is the direction of x, or this is the direction of x. So along this is x. Along this vertically inside to the plane, which is going, that is our y. And above this, it is the positive z, and below this is the negative z. Now let's consider, as we previously assumed, that the direction of the current is the current element is towards the positive y direction. So the direction is inside the plane. So there will be multiple these types of elements. Now let's say we want to calculate the value due to a point at P. Okay, try to understand one thing. Now we are not thinking about the value part. What is the value? That is a thing of the letter. Now we want to focus on the direction of this. So let's say there is a point P. The P point may be anywhere. Just a P point must be above the plane. We will consider the case of also below the plane. Now we are just considering the case of above the plane. So the current is going vertically inside this. So from the right hand rule, we can say if the current is going this, then the clockwise rotation is the rotation of H, or the magnetic field. So if it's going in this direction, so this will be the clockwise rotation. See, this is going to this direction, so this will be the clockwise rotation. So for this element, we can say this is it, the direction of H. Now if I make the radius of the circle from this center to the P point, let's say this be the radius, so it will be the H loop will be something like this. I know it's not a perfect circle, sorry for my bad drawing. So at this point, the direction of H will be the tangential at this point, which is this. So we can see for this point, which is let's say this is perpendicular to P. So for this perpendicular to P, the tangent is also perpendicular, or respect to this. So it will be along which? It will be along a y cap, because it has no inclination over the plane or declination over the plane. So it will be only have a y cap component, and let's say the value is h1. So the value of h in this case will be, for at point P, for this component will be h1 a y cap. Sorry, I made a mistake. This is ax cap. This will be ax cap because this is the x direction. This is not a y cap, this is ax cap. Okay, so this will be h1 ax cap. Okay, now consider the same for this thing also. This is the P point and this is the perpendicular. Now we are interested in this one. for this element the edge at P point. So in the same what should I say, in the same way for this one it has a edge vector which circulates like this. Now if I expand this and make this as the radius, so it will be something like this. Sorry, it's not a perfect circle, I know, I'm saying again. So at this point for this element the direction will be something like this, which is inclined tangentially upwards, which has two elements. One is positive AZ and another is positive AX. It's positive AX, this is X, and positive AZ. So let's say the value is H2. Okay, the value of this is H2, the field, and it has both AZ and AX components. So let's say K1 AX cap plus K2 AZ cap. This is the H for this one. Now let's consider for this one also. Now we have considered for this one, for this one. Now let's consider for this one. The same way it will be something like this. And now if I make this is the radius, so it will be something like this. So for this the tangential component here will be this. So it has a positive X and a negative Z. Okay. Now understand one thing. If I consider only one single element, let's say this was my seed. So it is a combination of a multiple lines, right? It is a combination of a lots of infinite number of lines all together. So if I only take one single element, this acts as a line, right? And for a line at a point, the magnetic field depends on two things: the position of the point and the radius, right? How much distance. So overall the radius of the distance of the point, the coordinate vectors basically. So that so let's say for this point the position of the point phase. Now we are changing the elements. So if I are changing the elements, the R changes. So let's, if I consider this and this are uniformly distanced from this, so let it be L, let it also be L. So for this one and for this one, both will have the same mod value, right? This one and this one both have same mod value. Difference is this will have an inclining component, this will have a declining component. So this will be same and this will be negative one, right? Because the radius are same in both the cases, because they are equal distance. So the radius are same, just they have a different direction, right? So the value will also be H2, because here is also we consider H2. The constants will also be same, K1, K2. Oh yes, by the way, this K1 and K2 are the constants for AX and AZ. So this AX cap minus, now there will be minus because it has negative AZ direction, K2 AZ cap. Now for those all three components, I mean 1, 2, 3, for these three, what is the resultant and P? Let's check it out. So at P point, due to this, it is this. Now for this one at P point, it is this, and for this one at this point, it is this. And now, as we said in the previous page, these two and this are in equal in mod values. This difference is in their direction. So see, if we add those two, just this part cuts out, right? So here we can also say this is this component and has this component, also this is this component and this is this component. These are along AX cap, AX cap and AX cap, and these are along AY cap, AZ cap, and this is minus AZ cap. And as the magnitude is same, so this one and this one cancel out each other. So the resultant components along x cap, and if the value is considered, so this will be something like h1 plus 2 k1 h2 or something like this. So moral of the story is, for something like this, for this, for all the components, it will have direction towards a x cap. Now let's understand one thing. This has direction of ax cap. This is direction combination of ax and az, and this has also the same ax cap and different and opposite, I mean equal and opposite z cap. So az cap components will cut out. So there will be some component here also and some component here also, which are equally distance to each other, because as I said here, a sheet is combination of infinite number of lines. So in between there are infinite number of such elements. So for this component, there is compensating this component which cancels that component. So for this element, there will be compensating this element which cancels the z component. Eventually, every other element will cancel each other's z component, and this one has no compensating element, but this one itself is along ax as it is perpendicular. So the overall, I can say the overall field is directed toward ax cap, and the value is the total value for all these components, which let's say h1 plus constant into h2 plus constant into h3 plus dot dot dot, which I can say is equals to h. So from this we can say this direction h equals to h a x cap. Okay, we can say. Now let's take the case when the p point is below the plane. In this case we are considering the p point is somewhere here. Now in this case we are considering the p point is somewhere here. Okay, so in that case what happens? It will be something like this. So for this one, it is the rotation. So at p, it will be something like this, and this is the direction, and it will be directed towards negative ax cap, right? So for all the components, the everything will be same, just the direction will now be negative ax instead of positive x. Then it will be negative x instead of positive x. So the value will be something like h. The h is also the same h. Everything will be same. Just this direction changes, because at the upper point, due to the right hand rule, it is directed here, and for this point, it is directed here. From this diagram, you can clearly understand that. So let's see one thing. This was the plane. The direction of the current elements were in this direction at y. Okay, at y cap or y directions, the directions of these current elements. Okay, the direction of the current element, this y, and the points are either at z or negative z, which is above the plane or below the plane. And where are you getting the h vectors? Either a z cap or negative a z cap. So one thing we can generalize is the direction of h is what? The direction of h is h vector, right? And for the direction part, it is the direction of k vector cross the a n cap. See, it is something like this. The h vector is the magnitude of h into, for the direction for it is the direction of that k vector cross the perpendicular component. If this be at here, the point P, so this is the a n cap, the perpendicular component. So positive y into positive z equals to positive x. And if this is below the plane, it is the current component, it's y. The an component, it's along minus an. sorry, az, so it is y cross minus z equals to minus x, which we have got here. Or we can also say something like this. You can also say like this, and this is the generalized version of it. Okay, thank you. Now getting to the value part. Now let's complete the second part. Let's find out the value for an infinite sheet of current. So let's say this is the sheet, everything is same here. This is y, this is z, this is y, this is x. So now this is the current elements, which is k cap k vector equals to ky, as it is y directed, and ay cap. The ky represent is directed along y. Okay, so let this be an element, and along this we are taking an Amperian path. We are doing this by Ampere's law. So we are taking an Amperian path. Now this is directed this side. So by using right hand rule, we get this is the direction. So we consider the direction clockwise. Okay, sorry, anti-clockwise. Okay. So now let it be this be 1, this be 2, this be 3, this be 4. So in this closed path we have one path 1 to 2, another path 2 to 3, another path 3 to 4, another path 4 to 1. Okay, we are good at it. I am sure that you are getting what is this. This is a plane, and this plane is cut by another plane, this. Okay, I hope you are getting this. This is a plane, and like this, and this plane is cut by this one. I hope you are getting this. Okay, so in the direction part we see this, see the dimensions are same. This is z, this is y, this is x. So and the current also in same direction, this direction along y. So it will be this. We have just seen, and how I just explained how. Now what's Ampere's law? Ampere's law says that the integral h dot dl over an closed path is equals to the total current enclosed by the path. This is Ampere's law. By using this law, first we are finding this. So what is this? This plus this plus this plus this. Okay, for this path the h, for this path the h, for this we're going to think this means h dot dl due to this plus h dot dl due to this plus h dot dl due to this plus h dot dl due to this. We are doing this only. See, now h dot dl for 1 to 2. See, this height is small h, and this width is small w. So in Ampere's law, the path must be symmetrical and uniformly distributed along the element. So this is h by 2 and this is h by 2. Okay, and this is directed in minus az cap direction, and you see for z greater than 0 it is positive ax cap, and this less than 0 minus ax cap. So for this we can say, for this part it is positive ax cap dot product with h by 2 into minus az cap, and in the same way for this half product it is minus ax cap multiplied with the remaining h by 2 into minus az cap, as this is negative directed, but it is of no use because we are dot producting x cap with z cap. So ultimately it will be 0 in the next line. Now for this path, at s is below the plane, it will be in common action, and this direction is at negative x, right? This is at negative x. So it is minus ax cap dot product with w, the value, into minus ax cap. Okay, plus this one is in the same way, just one change is that this was the negative, this was positive of az. Nothing changes between these two, you can see, and this is of no use because ax cap with dot product z cap, so ultimately it will be 0. And for this element, you see we are taking this component, it is z greater than 0, and this is also in the same direction of x, so it will be this. So this both are same and hw. So ultimately the value of h dot dl over the path L is 2hw. Now we have to find the current enclosed. Now in the previous one I told you we are talking about current elements and I dot dl is equivalent to k dot dl. So the I will equivalent to k dot dl. So I enclosed, the current enclosed total is equal to this over the path L. Now we know what? We know that the dl is dx ax cap plus dy ay cap plus dz az cap. I only took dy ay cap because the other components will anywhere be 0. Okay, because we are dot producting with ay cap, so only ay cap component will contribute. So this is this, and this is along what? This is the limit is w, because 0 to w, whatever you say, the length is w. So ultimate output will be w here. Okay. So now if we equate these two, we can say this. So the result comes is this. And from there we set this, just putting the value of h here. Now we are getting this. So we can say h vector is equal to half ky x cap or minus half ky x cap, depending on the z value. If z greater than z, it is positive, or z less than z, it is negative. So just like the previous one, we just generalize it, taking the saying that h vector is equal to half into k vector. See, this was the k vector of our, so k vector cross product. This is not x, this is a cross product, cross with an cap. An cap is the perpendicular vector. So the value is ky. So if I cross, if the point be at this position, so what is k? Ky ay cap, and what is this ay cap, az cap? So ky ay cap cross az cap, which is what? Ky ax cap, which is this one. And if the point lies below here, so k becomes the same ky ay cap. And for the p point, what is an cap minus az cap? So k cross an cap equals to ky ay cross what? Minus this az cap, which is this minus half ky x cap. So it is the generalized form. Okay, thank you.